is Francis Rajamohan. He is a senior principal scientist in exploratory medicinal sciences at Pfizer Inc.
Thank you, Mary. All right, so it's time for a nap now. I think I can take a nap. So if I fall asleep, just wake me up. That'll be a good thing. All right, so I'm going to talk a little bit about so Cynthia has covered a lot of basics on E. coli expression. So I probably might skip some of my slides. I don't want to bore you with the same backgrounds. So whenever it's necessary, I will spend a few more minutes. So the overview of my talk is, this is basically just a background, just different protein classes. So I probably will go through pretty quick, and then some basics about what you need to know about protein expression. Then I'm going to some of the examples. So the examples I have here is, one example is how you can express a multi-subdomain protein complexes. And the second one is the expression in the presence of modulators or ligands in there. Then the third one is in vivo bioaccumulation and purification. And a lot of times this is going to be very helpful. So we found that it's very helpful doing the in vivo bioaccumulation using E. coli. And also a little bit about the expression in the presence of chaperones. Then I'll go another some brief discussion about the post-translational modifications in E. coli. Most of the time, we know E. coli doesn't have any post-translational modification, but there are cases where you will see a lot of post-translational modifications. All right. So the protein classes, again, I'm sure you are all familiar with this. Protein can be classified based on the cellular localization into intracellular proteins, extracellular proteins, membrane-associated proteins, or the integral membrane proteins. This is probably the most easiest protein to work with. You should be lucky to have a protein like this to work with. So it's a highly soluble proteins, and you can use any kind of vectors. You can use different tags, either N prime, C prime. You can use fusion partners, tag cleavage, and it works really good. And also, you can use all different type of expression systems, yeast, E. coli, insect cells, mammalian cells, and even cell-free systems works fine. And the second comes this extracellular proteins. They are a little bit tougher. E. coli is not the very optimum candidate for this, but there are some systems you can use it using the disulfide bond forming systems, which secretes into the cytoplasm. But it's, if you're using an insect cells or mammalian cells, you have to remember it often requires a buffer exchange, because when it secretes out, it comes into the buffer, and in the conditioned media. Usually the pH of that media will be a lot different than when you start with. Usually goes either on the acidic side or the alkaline side. So the first thing you do is, anytime you do the secretion system, you take the media, adjust the pH. You'll be surprised how acidic it can go when you express them. Otherwise, your protein will be completely chopped up. This is one reason you don't get extracellular secreted proteins not stable, or you don't see the protein. And then you need to do a buffer exchange as quick as possible. So you cannot do this on a Friday and put it in a fridge and walk away and come back on Monday. You are done.